In this video I'm going to use this simple circuit to play with two frequencies. So at the end of the video I'll go through the actual circuit and the circuit diagram and describe how it works. But I've got a low frequency oscillator over this side, I've got a higher frequency oscillator here, and I've got a couple of low pass filters to change the what's approximately a square wave into a approximately a sine kind of sawtooth sine wave. And then I'm going to mix them together here. I'm going to modulate the lower frequency on the higher frequency here. So to monitor the frequencies, I've got an oscilloscope over here, and I've got a speaker here which I'm going to amplify the actual audio of the frequencies on. And I've got a fly lead here which I can probe different parts of the circuit with. So to start with, I will take the probe and I will place it in the circuit over at this point over here. And that's the high frequency, and then the lower frequency should be here. I just have to adjust the time base. So the lower frequency is hard to hear, but it's about 14 Hertz. If I turn the volume up, I'll just turn the volume back down a bit again because I'll go back to the higher frequency again. I think that's about 400 Hertz, I think. And then if I go to this variable resistor here, this is where it gets the two frequencies get mixed together. So all it's doing is taking the actual output of the two oscillators and it's putting them through a resistor and a high impedance resistor and mixing them together that way, because the high impedance resistor means you don't kill the actual oscillators themselves by dragging too much current. The actual high resistance will actually mix the actual frequencies together because it'll only take a bit of current from each of the frequencies. But if you want to then take this result and actually use it in another circuit further on, you'd probably use an op amp to actually amplify this to a higher powered output and then use it again. You could do other things down the line. And then I've got, so this is mixing the two frequencies together. But if I come over here, this is modulating the two frequencies. So the lower frequency is being modulated on the higher frequency. So the higher frequency is actually producing this, and it's an amplitude modulation. So you can see the lower frequency at the top here, and that modulates the lower frequency on the higher frequency using amplitude modulation.
This is why I'm experimenting mixing signals. It's for my ColecoVision compatible computer because it's got a Texas Instrument display chip, and that produces luminance and color difference outputs. But I need to actually modulate a 4 point something megahertz frequency on top of the luminance signal in order to add the color. Now that's done with this integrated circuit here, which you find in ZX Spectrums and computers from the 80s like that. And that will actually modulate the color onto the luminance signal for you. And if you look back in a previous video of mine where I'm actually running a cartridge on this computer, the actual Time Pilot game, the sky in the game looks like it is actually trying to be blue. So that was kind of working there. But this circuit didn't work very well for reasons which I'll explain later in this video. But now I've got my version 2 of these boards, so the actual system board here, which hopefully should be working complete. Maybe a few extra minor updates may be needed, I don't know, until I actually get to run it. I don't really know. And then there's the AV board here, and I've tried to prepare this. I've still got the modulation circuit on here. I'm going to try and modulate it like it's done on the ZX Spectrum this time, and maybe that'll work. But if that doesn't work, I've also added a second type of circuit in here which I can experiment with, actually trying to modulate the actual color signal onto the composite output myself. But that's all sort of unknown at the minute. But at least I can at the minute get a black and white steady signal out of my ColecoVision compatible computer for now.
So I found this document, which is an actual document about the display chip I'm using. and if you look down here, it's actually got a Texas Instrument logo. So it's actually a document written by Texas Instrument for their own chip. So I thought, great, if they're going to show me how to actually do a circuit to actually display composite on a video from their display chip, then I'll use that. So that here in the top and right hand corner is the actual circuit they present to actually display composite video on a CRT display, because back in those days there wouldn't have been any LCD displays. I think that's where the issue came, is that modern LCD displays don't always handle composite in the same way that old cathode ray tubes do, and so I didn't get the display working particularly well using this. And the actual display chip I've got, I wasn't sure whether or not it was the circuit that wasn't working or the display chips that weren't working, but what I did was I took apart my Spectrum Plus and I unsoldered the display chip from there, the color encoder from there, put it in a socket, and I tried out some of my, because I got a few of these, I tried out some of them and they all seem to work okay. They seem to color encode in the Select Spectrum fine. So anyway, I'm not going to use this particular circuit because also it uses an op amp, which they're quite expensive to get hold of as well, and there should hopefully the Sinclair Spectrum didn't use op amps. So this is a part of the circuit diagram from Sinclair Spectrum, and it's about this LM1889 chip, which is a color encoder. And so here they're using a different circuit. They're not using op amps, they're just using transistors down here to actually mix the chroma signal into the luma signal. So I thought I'd try out this, and I wasn't successful in getting it working before I got my new set of boards, but now I've got my new set of boards, hopefully I'm in a better position to do some experimenting, but I still don't have colour on the signal yet. So this is a circuit diagram of the circuit I was playing with at the start of the video with the audio waves, and on the left hand side there's a couple of oscillators which are just flip-flop oscillators, one producing around 14 Hertz and the other I think was producing around 400 Hertz. And this bit here is a low pass filter, so that rather than a square wave I'm dealing with something a bit more like a sine wave, or that is more is kind of sine wave, sawtooth wave, and there's another low pass filter here for that one. And then it just goes through a couple of high impedance resistors to mix the signals, and you get the mixed signal coming out here. And to actually modulate the signal using amplitude modulation, the low frequency signal comes in to this transistor, which is a emitter follower transistor, and the actual amplitude is controlled by the base of the transistor by putting a high frequency into the base of the transistor, and the output of that is then the low frequency modulated by the high frequency.